Welcome, Year 11s, to another fantastic lesson of General Maths. So we are on to lesson 2 today. As I said in class yesterday, or whenever I sent this out, we're going to be doing Pythagoras in 3 dimensions. So learning intention, do Pythag in 3 dimensions. Success criteria, same as yesterday, but in 3 dimensions. So, before we start though, let's do a review. I have 2 questions here. They're both complex familiar questions because you need to draw the diagram yourself. What I want you to do is just pause the video here and have a crack at drawing those diagrams and then solving for the unknown that it's asked you to. And once you've had a go at that, unpause the video and I'll go through the explanation with you. Righto. Let's have a look. So question 1. A helicopter hovers at a height of 150 meters above the ground and is a horizontal distance of 220 meters from the landing pad. Find the direct distance of the helicopter from the landing pad. Correct to 2 decimal places. Okay, so we have a helicopter. I'm going to try and draw it. It's going to be not good because I'm not a good drawer. Okay, I was going alright up until that bit. There we go. It's got his little rotor over there. His little landing gears. Yeah, I lost the plot again there, didn't I? There we go, little helicopter. And we know that the helicopter is 150 meters above ground, and it's 220 meters horizontally from the landing pad, and it's asking us to find that distance there, x. So label my triangle, use a different color. X will be my hypotenuse, my C value, and then the 2 shorter sides are A and B. And we also know it's going to be a right-angled triangle because the height is measured directly up from the ground. Okay, so that gives us C squared equals A squared plus B squared. X squared equals 150 squared plus 220 squared. Square root both sides to get x by itself. Once again, guys, you can do it step by step or you can do it all in one, up to you. X equals the square root of 150 squared plus 220 squared. Remember, that should be in brackets in your calculator. Let's put it in and see what we get. The square root of 150 squared plus 220 squared. I got 266.27 meters. 266.27 meters. Cool. Question 2. Jack kicks a football from a tee, so we have a football on a little tee there, and it travels through the air in a straight line for 30.14 meters. So it goes through the air, 30.15, sorry, and it touches the bar that is 3 meters above the ground. So it's asking you to find x. So I'm going to go over here. So if we put in our A, B, and C, our 2 shorter edges, A and B, and then C. So if we set up our rule, C squared equals A squared plus B squared. C is 30.15. A is 3, and B is x. So I want to get x by itself, so I'm going to minus, so I'll go into my other color. I'm going to minus 3 squared from both sides, which gives me x squared equals 30.15 squared minus 3 squared. Once again, guys, you could solve all of these values beforehand. The reason I'm not is squaring a number with a decimal in it normally gives you a really big, ugly number, and I just don't want to deal with it if I don't have to. So I have x squared equals that, and I just need to get x by itself, so I need to get rid of the squared. To get rid of the squared, I'm going to square root both sides. So on the left-hand side, the square root of x squared is x. on the right hand side, the square root of 30.15 squared minus 3 squared is something. I don't know what it is, but my calculator does, so let's ask it. Square root of 30.15 minus 3 squared. Oh, I forgot to put the squared on my 30.15. That almost gave me the wrong answer. There we go. And I got 30.000375. So rounding to 2 decimal places, 30 meters. So he was about 30 meters away from the posts. Okay. So ladies and gents, on to today's lesson. Like I said, we're going to be working in 3 dimensions. So, we're just going to get straight into it, essentially. We have a cube here. Each of the sides are 5 centimeters. We want to find the lengths correct to 2 decimal places of AC. So AC means the line from corner A to corner C, and then AD, the line from corner A to corner D. So we've sort of got two right angle triangles here. I'm going to draw them in. I'm going to do the AD one first. You can sort of see that we've got a right angle triangle there. So I know that that is 5 centimeters, but I don't know what that diagonal one is, and I don't know what the one along the bottom is. The other triangle I have is the one along here. I hope this is easy to see. Well, I know that those 2 sides are 5, and I don't know what the diagonal is, and the right angle would be in there. So really, I'm going to redraw those in the same colors here. We've got 5, 5, and that would be our X. And then on the green triangle, you see that the bottom edge of the green triangle and that diagonal edge of the red triangle are actually the same. So if we draw our green triangle then, it looks like this. On the bottom, that's the X side, and then that's there, and then we'll call that one Y, I suppose. So can you see, to find Y, we're going to have to find X first, because once I know what X is, I know 2 sides and I can find the third. On this first red triangle, I already know 2 sides, so I can find the third. Let's do it. I'm going to use Galaxy Pen for this one. So we've got side A, B, and C. C squared equals A squared plus B squared. Maybe Galaxy Pen's a poor idea. Oh, I'm committed now. X squared equals 5 squared plus 5 squared. Now I happen to know 5 squared is 25. 25 plus 25 is 50. X squared equals 50, which means X equals the square root of 50, which is some number. Let's find out what it is. The calculator's turned himself off. Square root of 50, 7.07. And we're working in centimeters here. So that was, if we put our answer back up here, AC, so the corner from A to C, was 7.07. Just a note, guys, try not to get confused between the corners, which the textbook has labelled A, B, C, D, and the sides of the triangle, which Pythagoras uses A, B, C, and D as well. What you'll notice is the corners of the triangle we label with capitals, and A, B, and C we label with lowercase. So hopefully that helps keep it clear. Okay, if we look at the second triangle, side Y is that side A to D. So that side there matches up with that side there. And we know from the previous triangle that X equals 7.07 centimeters. So I might use blue this time. Just keep it original. C squared equals A squared plus B squared. And C we said is Y. The hypotenuse is we're calling Y. A squared is, sorry, I didn't actually write what my A, B, and C are. A is 5. And then B is 7.07. And then what I'm going to do is I'm going to square root both sides, which gives me y is equal to the square root of 5 squared plus 7.07 squared. And that equals 5 squared plus 8.66. Your calculator might give you a slightly different answer based on rounding, but it should be around that. Close enough. Okay. I'm hoping that's clear, guys. With like I said, using Pythagoras rather in 3D, it essentially just uses. Let me try this sentence again because it's getting away from me. Pythagoras in 3D generally just means using Pythagoras twice. First to find one edge and then to use another edge. It's just all about identifying where those triangles are and going from there. So let's have a look at the next question that we're going to do. We're going to find the length AC correct to 2 decimal places. So I'm going to do this one in green, I think. Let's do it in green. So I'm going to draw in my triangle AC. Well, let's think about where could we do a triangle AC? The easiest to me, it looks like, well, we know that it's a square-based pyramid, so we know that that's a right angle in the corner. So it seems like that is going to be the easiest way to do it. So if we redraw our triangle down here, we've got 25, 25, and then that'll be our X, and that's AC. And that'll be B down in the corner. So we can find the value of AC. Once we've found the value of AC, it wants us to find the value of EF, and that's going to be a little bit trickier. So let's do the AC bit first and go from there. So, there we go. This is going to be my hypotenuse and my small side. X squared equals 25 squared plus 25 squared. X equals the square root of 25 squared plus 25 squared. Square root 25 squared plus 25 squared. I got 35.36 once you round. Okay. Now the next triangle we've got to find, I might do this one in blue. Can you see that we've got this triangle here? So I'm going to redraw it here. Got a right angle down in that corner there. We don't know that one, so I've already used X. We shouldn't use the same variable twice in the one problem. So I'll call that one Y. We know the hypotenuse is 26 centimeters. Ooh, I didn't include centimeters in my answer. That was naughty. In the last one, I fixed that up. And now in the last one, the two sides matched up, but what can you, looking at that, look at AF compared to AC. I'm hoping you can see that from AF will be half the distance of AC. So I'm just going to write that over here. AF equals 1/2 of AC. And we figured out AC was 35.36. Which, if we put it in, times answer, got 17.68 centimeters. So that would be 17.68 centimeters. So this, guys, by the way, would be a complex familiar problem because we're having to do a bit of chopping and changing using our brains to figure out what's what in this one. So let's do our formula. C squared equals A squared plus B squared. In this one, C would be 26, and then A and B. So 26 squared equals y squared plus 17.68 squared. I just realized I might be going a little bit fast with where the hypotenuse is. The hypotenuse is always the side that's the longest, obviously, but it always is opposite the right angle, so it'll never be touching the right angle. So it's really important to figure out where your right angle is, because that will tell you where the hypotenuse is. A really common mistake is people just always put the unknown as the hypotenuse, and that causes errors. Like, you'll never get the right answer if you put the things in the wrong spots. Okay. So let's solve this. Once again, I'm not gonna do the squareds because there's decimals involved, and that always makes it annoying. You don't want to square things that you don't have to. Or at least get your calculator to do it all in one step. So I'm going to get y by itself. To get y by itself, I need to get rid of the 17.68 squared, and I need to get rid of the square on the y as well. First, I'll get rid of the 17, minus 17.68, minus 17.68, which gives me y squared is equal to 26 squared minus 17.68 squared. Then I'm going to square root both sides to get rid of that squared attached to the y, which leaves me with y equals the square root of 26 squared minus 17.68 squared. And if we put that in our calculator, square root of 26 squared minus that squared 19.07 with rounding, and we're working in centimeters. So there you go, the height of that pyramid is 19.07. It has asked for 1 decimal place there, but always go to 2 is a good rule of thumb. That way you're always practicing what you need to do. Okay. We have one more problem we're going to go through together, guys. And this is more of a complex familiar problem because you've got to draw the diagram yourself. So there's a bit of extra steps going on. Now, I believe I did steal this from the textbook work, so you might see this on the worksheet that we go and have a look at in a minute. Okay, so in a primate enclosure, a rope is attached from the bottom corner of the enclosure to the opposite top corner. If the enclosure is 8 by 10 by 12, what's the length of the rope? Okay, so let's draw our situation here. We know it's a room, and it tells us it's 8 by 10 by 12, so it's obviously like a rectangular prism. So let's draw that. Hopefully not too dodgily. I'm trying to make it nice and... Oh, that's really poor dimensions. Let me try again. Okay. So we know that it's 8 meters by 10 meters by 12 meters. It doesn't matter where I put those. And what I want to do is I want to find a rope that goes from that bottom back corner to that front corner. And what that essentially is going to be, if I draw in a triangle, you're going to have that. Can you see the 2 triangles I'm hoping, guys? You have the first one. I might use highlighter for this. You have the first triangle that you can find the hypotenuse of, and then you're going to have the second triangle there. I'm hoping that's reasonably clear. So let's do triangle 1. So you've got your triangle, it's 8 by 10, and that'll be your x. And your second triangle, you have 12, and you know that that bottom edge is whatever x is. So once you have x, you can then solve it for y. Okay. Hypotenuse, short side, c squared equals a squared plus b squared. So x squared equals 8 squared plus 10 squared. X equals the square root of 164. I'm just doing that in my head because I'm tired and I want to finish the video, guys. But of course, if you just do 8 squared is 64, 10 squared is 100, add them together. And the square root of 164 is 12.81 meters, based on rounding. So we can say over here equals 12.81. Then, if we label our triangle, we've got our hypotenuse is C. Our hypotenuse is Y, sorry. No, it's small side, small side. C squared equals A squared plus B squared. C is Y. Y squared equals 12 squared plus 12.81 squared. Y equals the square root of 12 squared plus 12.81 squared. And put that into our calculator. Square root of 12 squared plus 12.81 squared. 17.55 meters. So there you go. The rope connecting the bottom to the top corners, opposite corners, would be 17.55 meters long. I'm hoping that's reasonably clear, guys. It's obviously very difficult not knowing where you guys are up to, not being able to be in the room with you. So if you're really stuck, please email so that we can see how you're going. So like I said, that's it for me today, in terms of the work that we're doing. What I want you to do though, in your individual folder, you will have the class worksheet. Once again, I've highlighted the ones I want you to do. So can I get you to solve question 2, question 4, question 8, and question 10. Yeah, question 11 is the one we just did together. So in terms of difficulty, question 8 and 10 are both complex familiar. So you might have to think a little bit to figure out how to solve those ones. Okay, like I said, guys, any questions, please let us know. But otherwise, I will catch you later. Have a good one.